So our main goal in the next 5 minutes is to have a simple explanation about blockchain technology so that everyone can easily understand the basics behind it. So let's get started. The first thing for us to do is to define and differentiate between two basic terms, Bitcoin and blockchain. Firstly, Bitcoin is a digital coin. Blockchain, on the other hand, is a technology that enables the moving of these digital coins or assets from one individual to another individual. Bitcoin is not blockchain. Simply put, blockchain is the underlying technology and Bitcoin is one of its applications. Let us take a look at one of the key issues blockchain attempts to solve, payment transfer. We will simplify the following example and keep the explanation at a conceptual level. In our example, person A based in the US wants to transfer $100 to person B based in Hong Kong. In a traditional transaction, A orders a third party, for example a bank, to transfer money to B. The third party verifies whether A has sufficient funds, identifies B's bank account, and moves the money, minus a fee. This process typically takes 3 days. With blockchain, we eliminate 3 elements in the transaction. Firstly, no third party will be needed and people can interact with each other directly on a peer-to-peer basis. Secondly, there would be a shorter waiting period with a faster transfer. And thirdly, the fees are relatively lower compared to what the third party would collect to facilitate the transaction. Let us dive into how blockchain addresses this in a payment transfer scenario. We'll be going through 3 key principles. The first principle we'll talk about is the concept of open ledger. Let us take an example where 4 people want to transfer money between one another in the form of Bitcoin. To keep it simple, we'll note the monetary amounts in dollar terms. At the start, let's assume that A holds $100. A then moves $50 to B. This is entered and then linked to the existing transaction on the ledger. Then let's say B moves $40 to C. We once again link this transaction on the ledger. And finally, C moves $30 to D and we end up with a chain of transactions. This chain is open and public to everyone on the network, so everyone on the network can see where the money is, how much money each person holds, and therefore they can determine whether a transaction is valid or not. For example, if A then tries to move $100 to D, this is not a valid transaction because A does not have sufficient balance and this transaction will not be added on the ledger. Now we'll take a look at the second principle, which is the concept of a distributed ledger. In our example, we refer to a centralized ledger where the chain of transactions are recorded. However, the power of blockchain is that we can remove the centralized party and distribute it across the participants in the network, or as we call them here, nodes. As such, A can hold the ledger in his node as B, C, and D can do the same and hold the ledger in their respective nodes. And anyone else who joins the network can hold a copy of the ledger and hold the chain of transactions. And with that, we have a distributed ledger and this removes the need of having a trusted centralized party to hold the ledger. We have achieved the goal of decentralization in our payment network. So that sounds great, but if you think about it, we've created a new problem with this structure. Because now we have various copies of the ledger on the network, and therefore we need to ensure that all the participants see the same version of the ledger. This leads us onto our third principle, which is the concept of mining. In this example, we illustrate how nodes in the distributed network works together to update the ledger in a synchronized manner. Let's assume that B wants to transfer $10 to D. B will publish and announce this transaction to the network. Everyone can see B wants to transfer the money to D. At this stage, this is an unvalidated transaction and has not yet been entered into the ledger. In order for the transactions to be validated and recorded into the ledger, miners will need to be involved. Miners are special nodes who compete amongst themselves to take an unvalidated transaction, validate it, and then put it onto the ledger. The first miner who does that gets a financial reward, which in our context is Bitcoin. In our example, let's assume A and C are miners. In order to be the first to win, a miner needs to validate the new transaction, which is relatively easy as the ledger is open and you can immediately calculate whether B has sufficient funds to make the payment. After that, miners need to find a key, which enables miners to lock the new transaction into the previous transaction on the chain. In order to find the key, the miners need to invest computational power and time because the search is random and miners need to keep guessing until they get the right key. The first person to do that will get a financial reward in the form of cryptocurrency, in this case, Bitcoin. This financial incentive ensures that collectively, the network can agree on the official ledger that should be used by everyone. Let's assume that C wins and is able to validate the transaction. They add the transaction to their own ledger and shares the key to the rest of the network so everyone can add the transaction to their own ledgers. The competing miner A will see no point in validating the transaction as the reward has already been taken. They are therefore incentivized to add the transaction into their own ledger and continue to find a new transaction to validate. So what is the point of this, you may ask? What is the benefit of having a decentralized system? Well, a decentralized system allows you to trust a counterparty without having to know them. You have this trust because the ledger is distributed and is maintained collectively by all parties in the network. Therefore, no one party can influence and manipulate the transactions that are on the ledger. So now you know that blockchain is not Bitcoin, but rather the underlying technology that supports Bitcoin as one of its many applications. You have also built the basic foundation in your understanding of how a blockchain transaction works, as well as some of the benefits it has compared to a traditional transaction with a centralized third party. In the next section, we'll take a deeper look into how a Bitcoin transaction works.